You said 29. Well, let me take a peek.
Can you maybe do one of these comparing growth rates problems?
Sure.
So either, something between 49 and 53. Let's do 49, maybe.
So in 4.7, number 29. Aha. Don't listen to me. I can't count. So, you guys, in trying to evaluate this limit, does everybody agree that when I try to allow x to increase without bound, actually, what is happening as x increases without bound?
That's what I ran into. I thought the domains were strictly between negative root 2 and root 2.
I agree. What number is this?
And
Did I write it down wrong?
What's the question?
The question is evaluate that limit.
You don't need these little delta?
I don't think you need it. Yeah.
You guys, I'm so sorry for the question. I'm sure the author did not mean this. I really apologize. I mean, the limit does not exist clearly because I think as x increases up bound, those values of x aren't even the domain of the function. Do you see my point? Seriously. It's a complete typo. It's a complete typo. I'm sure what he really meant, can I change the question? I'm sure what he really meant was this. So can I change the question? Because the previous one does not exist. And if I change the question, I don't know, how do we answer the question? Well, just panic, say something.
Well, 1 over x cubed.
What about it?
You multiply top and bottom line.
Is that what the author intended?
Probably not.
Yeah, probably not. He probably intended you to use L'Hopital's rule. Because when you evaluate this limit directly, you get an infinity over infinity situation. I think it's goofy. I like what David said. I would not apply L'Hopital's rule. But since that's what he intended, can I do it his way?
Sure.
Using his technique, which I think is way too much work in this example, I think since I get an infinity over infinity situation, I will apply L'Hopital's rule and rewrite this as a limit as x plays its game of the ratio of the derivative of the top to the derivative of the bottom. You guys, if I'm skipping too many steps, just please tell me. But would you not agree that the derivative of the top is differentiating the square root of something whose derivative is 1 over twice the square root of that thing? Whoops, is that a 4? However, the chain rule says multiply by the derivative of the top. I think in this case it's just simply an 8x. Over the derivative of the denominator, which is nothing more than a 9x squared plus 1. Please be honest again. I know we're ending the semester, but you're paying money to be here. Did I skip too much? Does everybody clearly see how I correctly applied the quotient rule? Come on, in harmony.
Yes.
No, I never applied the quotient rule. I just simply rewrote the limit of this ratio as the limit of the ratio of the derivative to upstairs and derivative downstairs. It's not really a quotient rule, is it?
No.
Good. We got a final exam in 2 weeks from tonight, right?
We do?
Probably.
Are you
Probably.
positive?
No, I'm not.
Is that a rhetorical question?
What's next? What's next?
Can you clean it up?
I got a question.
Oh yeah, you can get the 2 out of there, and yeah.
Oh, you know what? I didn't even see that, Bradley. I agree. I suppose I can cancel 2's upstairs and downstairs. That's not a big deal. But
Yeah.
what's the deal? Oh, do I have a L'Hopital rule situation? L'Hopital's rule situation again?
No.
Oh, so you're saying it's not an infinity over infinity situation?
No, it is.
No, it is. It is. And if I apply
Oh,
L'Hopital's
I
rule
didn't see
again,
the X then.
the dirt at the top is nothing more than a four, but the dirt at the bottom is gonna require the product rule. And so I've got the first as is, times the dirt of the second, plus the second as is, times the dirt of the first, which is 1/2 times the square root of all that garbage. Oh, but then I gotta multiply by the dirt of the inside, the dirt of what I'm taking the square root of, which is 8x. Wow, you guys, looks like an absolute mess. First things first, more cancellation with coefficients. What's next? Seriously.
You should put the bottom into a
Common
one
denominator.
fraction.
I'm too tired. I could be more lazy.
We could multiply the top and the bottom by root 8 plus 4x
There's
squared.
nothing wrong with what you said the first time, but I just think that's easier. With my green pen, why don't I, just clean up this fraction by multiplying top and bottom by the denominator of the smallest fraction, which is root garbage. Multiplying top and bottom of this beast. You guys awake?
Yes.
If you're awake, what do I write next? What do I write next?
4 times
I can't hear you.
root.
Nothing because
Nothing,
that's
because
not
I'm not
L'Hopital.
applying L'Hopital's rule. All I'm doing is massaging the expression within the limit, and I just think I'm simply saying that the limit of that garbage is equal to the limit of this garbage, which, by the way, is nothing more than 4 root 7. All over, I really have no clue. Is that an 8 plus 4x squared? Times 18x. Is that a plus 4 times 9x squared plus 1? Which, by the way, is nothing more than the limit as x does its thing, of the ratio of 4 times root stuff times, yikes, I really have no clue. Is that a 4 times 18 times x cubed plus 8 times 18 times x plus 36x squared plus 4? I don't know, what is next?
You can
I have a
get rid
question.
of the 4 on the top and the bottom.
You know what, I'm sorry, I didn't see that. You are right. If I cancel a factor of 4 upstairs and downstairs.
Yeah.
You guys, I'm just getting tired.
Couldn't
Do
you
you,
just,
do you think we can stop? Because it's just not going to end, is it? I'm getting tired. And this is just not going to end, is it? Maybe. Come on, let's play some chess.
It does end.
What do you mean it does? How?
Well, there's an answer.
No, don't look at that. Why, look up here. Why is it going to end?
well, back here, don't you have 4 over infinity? Could you just stop there?
And just say
You
it's
know
0?
what? I don't know. I'm nervous. Because technically speaking, if I distribute the limit in here, 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 and here, I think I got the limit at infinity over infinity. I don't know what that is. Since I don't know what it is, I'm in trouble. It's really because I've got the limit of infinity over infinity here. When I allow x to increase that amount, I can't stop with the process. Do you see my point? It's just that applying the limit to this particular term is an indeterminate form. I've got to keep going. Come on, you guys, let's play some chess. Is my next step going to really end the process?
Sorry,
Reason.
I missed the part where you went from, how'd you get the 8 and the 4? See how you from the top, you went to the bottom? Like, there's no 4 on the denominator, there's no 8 on the denominator. How'd you get those there?
You mean this 4 right here?
No, on the denominator.
That
It's
one.
the 18.
This one right here?
Yeah. 8.
Um,
And then the 8 next to the 18 again.
You know, all I was doing is I was trying to effectively remove parentheses. I'm saying 18x times 4x squared is this. I was too lazy to multiply 4 and 18. I just wrote it as 4 times 18. And then I got my x cubed. And then I said I've got an 18 times 8. I was too lazy to multiply the garbage out.
I don't know why I did.
No, it's okay. It's because I swapped terms, that's why. I want an answer. Is one more step gonna work?
No.
I was hoping you'd say.
Yes.
Yes, I think it'll work because when you differentiate the numerator, what do you get? Don't be careful, be lazy. What do you get? I think you get an x over some garbage with square roots. There's a factor of x upstairs. But when you differentiate the denominator, shoot, each and every one of these terms is going to have a factor of x. They cancel. I think playing chess, I clearly see that my next step, if I apply L'Hopital's rule one more time, I will not have any variable factors upstairs. Which means when I've added the limit, I definitely will not have a 0 over 0 or infinity over infinity situation. Do you see my point? I'll show you what I mean. I'll show my steps. I think in applying L'Hopital's rule one more time, I've got the limit as x plays its game. Let's be slow. I think the derivative at the top is differentiating the square root of something, which is 1 over 2 times the square root of that thing. I'm so sorry, you guys. Chain rule says I gotta multiply by the derivative of what I'm taking the square root of, but that's just simply 8x. All over the derivative was downstairs, but that's just 3 times 18 times x squared plus, I don't know, is that 2 times 18 times, is that really an x?
Yes, so
Oh,
this is
shoot,
2
I could
times
be wrong
18.
then. Plus, derivative of this term, which is 9 times 2 times x. Oh, you guys, I'm disappointed. I didn't realize there's only one factor of x here. I thought there was a couple of them, which means I'd be able to cancel my x's. I don't know, what's next?
Another L'Hopital.
Yeah, you know, there is another L'Hopital's. I'm kind of nervous because that means I'm going to have this thing pop upstairs again. You know, I'm starting to think using L'Hopital's rule, I'm not going to end this process. I really looked ahead and I thought I would.
And you didn't believe us.
Well, I didn't believe you.
There are quite a few like this where it just kind of went on and on and on and on.
Can we just do this? No, I'm serious. Can we give up?
Oh, that's awesome.
I mean, you know, when I first looked at this example, I just said, let's apply L'Hopital's rules before the author intended. I think in this example, this is so horrendous. I would never apply L'Hopital's rule. I would have done this. You guys help me with this. Is it 8 plus 4x squared underneath the square root?
Yes.
Just so I don't have to look. What's the denominator?
3 times 3x.
No, the
3x
3x
cubed.
cubed.
3x cubed plus x squared.
Plus x minus 1?
Yeah.
And we're taking the limit as x increase up now. You know, not even the conjugate. I would have done this. Clumsy hands. What's the highest power to which x is being raised upstairs? 1. What about downstairs? 3. But you know, if I multiplied with my red pen, top and bottom of this fraction by 1 over x to the highest power I see downstairs, I think what that generates is nothing more than a limit as x increases without bound. I don't know what that's left over. Is that the square root of 1, or excuse me, I misspoke. Is that 8 over x to the 6?
Yeah.
Plus 4 over x to the 4th. You guys be honest.
Yes, I see that.
All over 3 plus 1 over x squared minus 1 over x cubed. Ah, shoot,
That's
no
just 0.
L'Hopital's rule. I think piece of cake, when I value this limit as x increases up bound, this factor, or this term, excuse me, goes to,
0.
goes to,
0.
goes to,
0.
goes to,
0.
goes to,
Stays.
it stays. And so I think in the end, I'm merely left with 0 over 3, which by the way is
0.
I do think this is an example where repeatedly applying L'Hopital's rule is just not allowing me to evaluate the integral. I'd rely on my old techniques.
You just said evaluate the limit, right?
Yeah, just evaluate, not use
So you
L'Hopital's.
didn't have to use that, so that's probably what we should have done.
No,
Oh
I
my
know, I
God.
just want to illustrate that Sissy wanted you to look at
You don't know
L'Hopital's
how
rule.
long I
Understand
spent on
this
this
example
problem.
just doesn't help. I keep cycling back and forth, back and forth.
Is there any way to like anticipate that? Just by looking at
Always, always. As a matter of fact, as a general rule, whenever I'm taking the limit of a ratio where I've got square roots and polynomials upstairs and or downstairs, I always use this technique. Don't take that the wrong way. Sometimes L'Hopital's rule does work pretty quickly, but not always.
So on a test, if we just solved it like that, I mean, would you care or
Quite the contrary, I'd love you to solve it like that.
instead
I'd
of
love to
using
sit back
L'Hopital, or
and say to yourself, it's just so much easier.
would you ever put on a test that you just want it solved using L'Hopital, or?
You just say
Well,
evaluate.
You wouldn't get that.
You know, maybe on a regular exam, on a final exam,
Yeah.
emphatically no.
No?
To me, on a final exam, you're supposed to stand back and say, I know what to do.
So is L'Hopital's rule ever better than
Dramatically.
it is?
I'll give you an example in just a second.
Okay.
David?
For the, isn't it when you have a 0 over 0 situation when you evaluate the limit and then infinity over infinity, and the variations of that is when you apply L'Hopital rule?
What do you mean variations then?
Well,
Like zero times infinity or infinity
Yeah,
minus
0,
infinity?
exactly, yeah.
How about saying this? Excuse me. Directly, I'd apply L'Hopital's rule if I get a 0 over 0 situation or infinity over infinity situation, but there are other indeterminate forms like 0 times infinity in which I can finagle it so that I can apply L'Hopital's rule.
Oh, that's right.
So if you continue just doing L'Hopital's rule, do you think, would you ever get to the answer?
Can I stall for
Yeah.
5 seconds before I answer your question?
Okay.
No. No, Brad, my answer is no, because emphatically, no matter how many times you differentiate the denominator, you're gonna have one factor that's 1 over root stuff, which has to be thrown upstairs. You're always gonna get x upstairs if you repeat this repeatedly, indefinitely.
So I did it like 6 times.
Yeah, I foresee that it doesn't matter if you apply it 25 times, you're still gonna get a root involving x's upstairs. It's never gonna happen. You guys okay with that?
Yeah.
I think that was intentional in the book. There's one part where it says use L'Hopital's rule to do it, and then the next section says just evaluate it.
You know, that makes me happy, because I'm not a great fan of this author, and I personally didn't think he was, I'll stop talking.
Oh no, please.
I formed a subcommittee to meet immediately on Friday. We were discussing this book. No ifs, ands, or buts, we're not continuing.
Write your own book,
Wait, so summer's gonna be a different book?
I can't change things this summer, man.
Oh, okay.
It's too soon.
Write your own. basically.
Write my own. I teach too much.
You should save all the problems you do, like,
Yeah,
like this
actually, that
problem
one.
right there where you like changed it, like you had some sort of variation to it, then you should like write it down and then make like a PowerPoint.
Everything that's wrong with this book.
I can't write that much.
Sounds really stupid.
Well, what would happen if we go back to that, the other one that we used last time? I thought that was, yeah, I thought that was a pretty good one. Because I reference it a lot and it seems pretty straightforward.
And you gotta go out and pay another $200 for a calculus book.
Yeah, no, I understand that, but the people that have it at least, finish it off.
I don't know how to respond to that. Stewart is really good in having 1 foot in reform calculus, 1 foot in traditional calculus.
Uh-huh.
And I think for all the text out there for calculus that try to go both ways, it's the best. I just don't know if I appreciate the rigor of it. There are a lot of issues I have mathematically speaking with the theory behind the text. There are a lot of people across this country who aren't pleased to see him build this $5 million house up in Canada, wherever it is.
No.
It's just hard. It's such a money-making gimmick. It's just really hard. That's just my opinion.
All
Yeah. Yeah,
textbooks are like that though. They change like the edition every 2 years. It's like
I know.
a minor difference, like chapter 13.
Well, no, now it's supposed to be, they want to have a new edition every 10 months.
Oh, 10 months,
10
sorry.
months, they want now.
It's the
Bubbles.
same thing for physics textbooks.
That's fine.
No, I'm fully aware. I understand the gimmick of
Just
just having.
slow
revisions.
flow through you.
It's not like calculus has changed.
Has calculus changed?
Has it changed very much in the last 5 years?
Every time you
I think it's time to change this.
Yeah, that's a better question, isn't it? Maybe not at this level. I think maybe in terms of examples in text that might draw your interest, they should be updated in terms of where we are historically speaking, but, that's a hard one. That's a really hard one. The teaching of mathematics has changed quite a bit. I mean, how many computer scientists majors are there here? Only a few of us.
Like
Wow.
2?
For computer scientists, everything I've discussed this semester may not be that significant for you because you don't deal with continuous variables. You deal with discrete variables, variables that rely on values like 1, 2, 3, 4, 5 on up. Not one and then the next rational or real number. Not that there is a next real number, but you're dealing with discrete variables that only have finite values or finite increments of variable. And so I think for you computer scientists, studying something like discrete mathematics is more appropriate, as opposed to continuous mathematics like this is. So I think the way we study mathematics has changed depending on what your emphasis really is. I don't know who. Somebody just asked, well, give me an example where I can't play this old game. Look at this example. I just make this up out of thin air. What about the limit as x approaches 0? You guys, I'm sounding so slow. How about the cosine of x? Minus 1. All over x squared. Let's see if you and I can't evaluate that limit using our traditional techniques. So multiplying top and bottom by 1 over the highest power of x I see downstairs. You guys, is this really helping?
Yes.
See, I don't know if it is or not, to be honest. I really don't know, because what are you going to do with the limit of the cosine of x over x squared?
You can't do a thing with it.
Really?
Equals 0.
Squeeze theorem?
Yeah.
You know what, you guys? Now that I'm looking at it, maybe I can do something with it. Can I make a slight change? This is too easy. Can I make it more complex? My apologies. How about minus 2? Plus e to the x. Sorry.
Okay, I see.
Now, I do think I have an indeterminate form, which is 0 of a 0 situation. Do you guys agree? It's just that when I multiply top and bottom by 1 over x squared, check out what I get. The limit. As x plays this game of the cosine of x over x squared minus 2 over x squared plus e to the x over x squared all over a 1. So let's talk about what this limit of values to. I think I get, shoot, red pen. What do you think?
Undefined.
See, I think that goes to 0. Think about it. As x increases that bound, the numerator is doing something kind of limited. It's just oscillating back and forth between 1 and -1. Nothing significant. But the denominator is increasing without... Oh, shoot.
Decreasing 0.
Sorry, I thought that was infinity. My apologies. As x goes to 0, what is this thing doing?
Undefined.
0.
I think it's doing this. Because as x goes to 0, that denominator's going to 0. That means the fraction is going to increase that bound. Positive or negative, I don't know which. I'll put a plus or minus. As x goes to 0, whoops. As x goes to 0, what is this thing doing? Infinity. What about as x goes to 0 here? See, I don't know. We'll have to do some analysis. Actually, I do know. But the point is, I get something like a 1 divided by a 0 situation. I mean, it looks like it's going to infinity, doesn't it? But you guys see how, unlike my last example, multiplying top and bottom by 1 over x squared, I don't think it's very clear what the heck is really going on. So I think here's an example, if I can erase all my red garbage, where maybe I should be saying to myself, L'Hopital's rule is the best approach. Unlike my last example, I'm not dealing with just algebraic expressions. I'm not dealing with expressions involving addition, subtraction, multiplication, division, and maybe square rooting. I've got transcendental functions involved. So I just think it'd be much more appropriate to dive in and say, well, trying to plug 0 in for x, I certainly get a 0 of a 0 situation. And applying L'Hopital's rule, I get the limit as x plays its game of the ratio of over 2x. And you guys help me with this. Applying L'Hopital's rule one more time. As x goes to 0, what's upstairs? I can't hear you.
Negative cosine.
No, say it louder.
Cosine?
I heard that. Why'd you say that?
Because that's true.
No, it's because when I plug 0 for x,
It's
what
just
do I get
gonna be
upstairs? 1 or 0 or infinity.
It's 1.
It's not 1 or infinity. Excuse me. It's not 0 or infinity. It's 1. It's not an application of L'Hopital's rule, is it? Alright, so I guess I can't apply L'Hopital's rule. I guess I'm done. Let's apply the limit. As x goes to 0, I think my numerator goes to 1. My denominator goes to
0.
0, which means the whole ratio
Does not exist.
Doesn't exist.
increases without bound, I think.
Okay.
Did you guys see it?
No.
No.
David, you don't.
No.
You don't like going from here to here?
Because you have a asymptote.
We'll do it this way, watch. As x goes to 0, don't worry about this term. If it goes to 0, no big deal. But as x goes to 0, I think the second term goes to 1.
Yes.
And so I think, use my arrow notation, this whole limit's going to 1 divided by,
Zero.
well, as x goes to 0, the denominator's going to 0. But if my numerator is getting closer and closer to 1, but my denominator is getting closer and closer to 0, I think this fraction is increasing without bound.
Oh, I see.
David, let me say it another way. If this thing is so close to 1, just call it 1. But if this thing's getting closer and closer to 0, you're not quite getting there like by 0.0000001. I think 1 divided by that thing's really close to 0 is going to be huge numerically speaking. And that's why I think this limit's going to blow up.
Okay.
It's just, you guys, this is an example where I don't think multiplying top and bottom by 1 over x squared is the appropriate approach. Because I don't just have an algebraic expression for which I'm taking the limit of. I think it's a big difference.
Okay.
Is that better, you guys? Okay. What can you say about this? Anybody? Anybody at all?
The top goes to infinity, right?
It does. What does the bottom go to?
N factorial?
No, you're talking too much. You're going way
Talking
ahead
too
of me.
much?
I'm just saying, if you add the limit, what do you get? Infinity over
Infinity.
infinity. I think both the numerator and the denominator increase without bound, so I think this is a good candidate for L'Hopital's rule. And when I apply L'Hopital's rule just one time, I think I get the limit as x plays its game of the ratio of the derivative of the top, which is nothing more than 1 over x, times the derivative of the bottom, which is n times x to the n minus 1. Oh, but shoot, you guys, in one full swoop, what does that value to? But you know, when the limit of this ratio is equal to 0, what it really means in English is that this expression downstairs, this function downstairs, grows so much more rapidly than the numerator. I might say it in English, that a power expression grows faster than a logarithmic expression.
Is there a way you can graphically just kind of just quickly sketch it?
Absolutely. Graphically speaking, here's what's really going on. The x-axis, the y-axis. If I were to graph, how about this green beast? If I were to graph this equation, I don't know, you guys help me. Where's the horizontal asymptote? Oh, there isn't one. But where's the vertical asymptote? Well, there is. How about at x equals 0? Where's the y-intercept? There isn't one, but where's the x-intercept?
1.
Yeah, 1 comma 0. I think the graph looks like this. Because of the curvature, or maybe concavity, do you guys agree that as x increases without bound, y still may increase without bound, it just doesn't increase without bound very rapidly. What can you say about the graph of this equation?
Parabolic.
It's parabolic, looks something like this.
Mm-hmm.
And a parabola is a collection of points that are
Symmetrical.
and holy cow, we're a huge class, one lone voice. A parabola is a collection of points.
Reflector of the y-axis.
Well, that's a quality the graph has, but the definition of a parabola is a collection of all points equidistant from the focal point, the focus, and the directrix.
Directrix.
Am I alone?
No.
Rings a bell.
That's trig.
Very relative.
Very relative. What's graph that look like?
Just go.
Yes, your disco function. What's the graph of this look like?
Fatter.
It's a parabola.
Okay, a fatter parabola. It's got the same stretch of parabola, not quite the same reflective quality, but just more extremis behavior. And if I look at y equals x to the fifth, it sort of looks like the disco function, just more extremis behavior. Don't you guys agree that the y values in the red curve, if you walk on the x-axis more and more to the right, take a really long walk, is it not the case that pictorially speaking, stop laughing.
Is he using one of his hands to walk?
It's a disco dance on the x-axis.
All right. I'm moving that way, okay? I think the y values in the red curves are getting bigger so much more rapidly than on the green curve. And we might say in English that these power terms grow faster than these logarithmic terms. You know, if n is equal to or above. Make sense?
Yes.
We're saying that the x is going to the infinity. So
And when I say, David, x is going to infinity, I mean, you promise not to laugh?
absolutely. I'm gonna hold it as hard as I can.
That means if I take a walk on the x-axis, further and further, I see the smile. I see it. I think if I take a walk further and further to right, in other words, as x gets larger and larger and larger,
Yes.
I do think the y values in the curve down below are getting larger much more rapidly than
I
the y
see.
values
I see.
upstairs.
Okay.
And that's why I think this ratio goes to 0. I might say in English that power expressions grow faster than logarithmic expressions. Oh, that was so fun. Let's do it again. What about the limit? As x increases that bound of the ratio of x to the n, choose something like, I don't know, how about e to the x? I want a yes or no answer. Is this a valid candidate for the L'Hopital's rule? Yeah, clearly it is. Because I think as x increases that bound, both the numerator and denominator increase that bound. The question is, does the numerator or denominator increase that bound more rapidly? Well, if we apply L'Hopital's rule n times, you guys help me with this. What do I get downstairs? E to the very nice. But if I apply L'Hopital's rule n times upstairs, what do I get?
And
And
x
x.
to the n.
Times x to what power?
None.
0 power, which is just 1. I want a yes or no answer. Is it a constant? It is. And so when I take the limit of the ratio of a constant to e to the x as x increases that bound, what the heck do I get? I can't hear you.
0.
Therefore, I think exponential functions grow more rapidly than power functions. I might even say in English, logarithmic functions don't grow faster than power functions, which don't grow faster than exponential functions. If you really want to classify rapid growth at extreme values, you can do that. I mean, I know I'm using funky notation with a double inequality there, but the same idea. Brad, I think you're the one who asked this question.
Yeah.
But am I making sense? Am I justifying what I'm saying?
That does make sense.
It's a math class, you gotta
Yeah.
attack me if I'm not clarifying.
That definitely makes sense.
For the bottom equation, you said that you,
You mean bottom example?
yes, sorry. So, you said that you applied L'Hopital's rule to the
N
n
times.
times?
Do you see why?
I do, I'm just asking if we were to get that on a test, would you grade that? Like, how would you go?
I want to see what happens after n applications of L'Hopital's rule upstairs.
Okay, so if that were the case, you would want it written as n factorial, but in normal circumstances, you would want n to be x to the n minus 1.
Okay, hold that thought. Let me write what you wrote, or what you said. You said this. Where did it all come from? Well, no, it came from the power, you're right. Differentiate top with the power gives you this. Where'd the whole thing come from? Where'd the whole limit come from?
Your head.
My head. L'Hopital's rule how many times?
Just
Once. However, as x increases that bound, do you guys not agree you get infinity of infinity again? Oh, shoot, I guess we gotta apply L'Hopital's rule again then. That gives a limit as x plays its game of n times n minus 1 times x to the n minus 2, all over e to the x. Ah, but shoot, now when you evaluate the limit, what do you get? Infinity over infinity situation. And Becky, I was skipping a lot of steps. I'm saying, if you apply L'Hopital's rule, collectively speaking, n times, I think you finally get the limit as x increases up bound, n times n minus 1 times n minus 2 times, all the way down to 3 times 2 times 1, all times x to the n minus n power, which by the way is x to the, which by the way is just, oh, gone. All over e to the x, no matter how many times you differentiate. But that's just simply equal to the limit as x increases without bounds of a constant over e to the x. Ah, shoot. That's a piece of cake. That's just a zero. Do you see my point?
I was just asking about how you would want it written, that's all.
I kind of like, I'd be really happy if you showed no work. You pop that in here. And maybe even rewrote the numerator as, like this.
Can you do a 43?
I hope I can.
No, we're in a room.
So 43 in the same section.
Yeah.
43, where are we at? Ooh, that's so nice. 1 plus x to the cotangent of x. I said 1 plus x to the cotangent of x, and we're taking limit as x approaches, I think, 0 from the right-hand side. So, question, is this really one of our indeterminate forms? I'm serious, I don't know, I don't look at it close enough. You know, I think as x goes to 0, the base goes to
1.
But I think when as x goes to 0, the cotangent goes to,
Infinity?
you know what? I think that is one of my candidates. May not be in an indeterminate form for which I can apply L'Hopital's rule, but certainly once the infinity power is an indeterminate form. Do you believe me?
Yes.
You sure? That was just one voice.
Yeah.
Maybe.
I heard a maybe. How about this? If this base goes to 1 so much more rapidly than the exponent increases that bound, I think this thing can go to 1. But if my exponent increases that bound so much more rapidly than my base goes to 1, I think the whole thing can go to infinity. Or maybe it's a battle, it's a race, and there's something in between that can happen. And that's why I would classify this as an indeterminate form, because it depends on who wins the race, the exponent going to infinity or the base going to 1. And if you guys are okay with me proclaiming that this is indeed an indeterminate form, let's see how we can evaluate the limit. Let's see who wins, the exponent or the base, or maybe a combination of them. So, you guys, let me consider the expression 1 plus x. Oh, I took my glasses off. Is that cotangent of x?
Yep.
You know what? That sounds so complicated. Can I just stop for a minute? Can I just give it a name? And if you guys allow me to come in and take the natural log of both sides. Oh, you guys, am I making things more difficult by taking the natural log of both sides?
No.
Yeah, I don't think I am. Because technically speaking, on the right-hand side of the equal sign, what I really have is a cotangent of x times the natural log of 1 plus x, just using my basic properties of logarithm. That was math, yeah, D. I heard that. And so now, if I take the limit of the left-hand side, that is to say, the limit of the natural log of y, as x increases, is it without bound? No, it says x goes to 0 from the right-hand side. I think this is the limit. As x approaches 0 from the right-hand side, of the product of the cotangent of x with the natural log of 1 plus x.